Hello and welcome to today's featured HOD interview, where we bring you closer to the people shaping the future of education, research and innovation. I'm your host, Nishita Shaiju, and today we have the privilege of speaking with Dr. S. Pranesh, Head of the Department of Mathematics at Christ University's Central Campus. Dr. S. Pranesh is a distinguished academic in the field of mathematics. He holds both a master's and doctorate from Bengaluru University, specializing in fluid mechanics. His research interests focus on stability problems, convection issues, and nanofluids. Dr. Pranesh has been with Christ deemed to be university since 1991, contributing extensively at both undergraduate and postgraduate levels. He has served as the coordinator of the PG department and organized several national and international conferences. Currently, he leads the Department of Mathematics at Christ University. Dr. Pranesh, welcome to the podcast. It's a pleasure to have you here.
Thank you.
To start, I would love to hear how your role as HOD influenced your perspective on teaching and leadership.
Regarding teaching, now I can focus on extending the curriculum. Especially nowadays, the people are thinking about the interdisciplinary research. So we can introduce in our UG and PG the interdisciplinary courses. So that as a leader, I can influence all my faculty members or my team members, and I can increase their trust on me, and their strategic thinking also I can evolve in that. As a part of research, in the curriculum research, we can think of from what I say is from theory to practical applications. So we have now theories. Most of the mathematical concepts are theoretical concepts which can be taken to the practical application, so that will help the students for their future also.
Right. So talking about research and application of research, what areas of research in mathematics do you think is the most important right now or holds the most promise?
See, one is, as for the current situation, applied mathematics is the one which holds most important. And you might have seen that in AI and ML, we use optimization theory, linear algebra, even topology we use in our AI and ML, and we have cryptography, coding, decoding subjects. Differential equation is the main in mathematical modeling. Mathematical modeling will not survive without any differential equation. So this is calculus. These are the main topics which will be useful. These are all the basic talks. Based on this, so many subjects are built on this with this basics.
So basically mathematics is a very important component with other subjects as well. So there's a lot of room for interdisciplinary collaboration. So how do you think that will help the field of mathematics over the next few years?
So one is modeling. Modeling will help to build the models that predict the real world problems. And data interpretations, where you use linear algebra again in that. And it gives a research to formalize and test the new ideas. Mathematics will give to test the new ideas what they have without exploring more on the cost, because other subjects they need to have a laboratory, they have to spend a lot on that, but mathematics with equations we can test the reliability, and it will give the deep patterns, how that research pattern, or we call in fluid mechanics there's a pattern, this one, all this we can develop or see by using a mathematics here.
So I believe these are all mathematics can be such a challenging subject. These are very complex topics that you're talking about. For your students, how do you break it down to them? How do you make the subject very engaging, very interesting for your students?
See, math subject we can teach. Interesting means we have to give, as I said, real life applications we have to give. And it should come from the student's point of view also. See, you cannot just come and stand, today I'll do the research problem. It's not possible. You should be good in basics. So first of all, students should master in the basic foundations. Like in calculus. You may not use what calculus you use in your undergraduate for research, but they are the basics required. If you understand that, you can understand the research component, the advanced level. and they have to read more textbooks, classical textbooks especially, because I don't think nowadays students will do. They depend mostly on the students' website or even teachers, whatever they give. But that is gives little bit only. But because if you read the same topic with different textbook, they explain the topic with different prospects. So you'll understand the different ways how it can be told in the class or in the other way. Okay, and you have to learn the mathematical computational tools. Without that technology and other things nowadays, you cannot solve the higher mathematics. So these are some of the things if they do, and more importantly, they should practice writing and speaking the mathematics. Because without that, usually students will read the mathematics. I feel that mathematics is meant only for writing, not for reading. You practice, you will become perfect.
Yeah, that's how you learn, right?
Yes, we learn like that only, because we had, in our case, we don't have any these online things, anything. We have to depend on textbooks, or we have to depend on our teachers, we have to depend on ourselves, how we can improve our understanding of the subject. Right. So now you have everything, but students are not using that properly. That is what I feel. They should write and practice speaking the mathematics.
The students should take up that initiative.
It should come from them only. Yeah. We cannot tell them, you read I cannot ask them to sit in next time and make them by heart everything. It is not possible.
I think all the students under your department, they truly have a passion for maths if this is the subject that they took.
That is one of the main aim of our department also.
So in terms of the department, how does the Department of Mathematics at Christ, how do you distinguish yourself from other departments and other institutions?
Yeah, we have, first of all, I can say when I compare with other, whatever we had as a neighboring and even other colleges through the website when we check, we have more computational tools integrated curriculum. Most of our courses, what we are integrated, especially in PG when you come, wherever it is possible, now we are introducing that CIA 3 component. It should be through these computational tools only. They can use Python program or anything. And our department is strong in research areas like fluid mechanics, graph theory, mathematical modeling, some of them. So we want to create a global collaborations and research outputs in it. And motivate more students to involve in this UG research, our undergraduate. PG, anyway, we have a project, internship, compulsory internship project, so they will be going for that. But in UG, now we want to motivate more students to involve in this, and we are planning to have a industry collaboration, research collaboration. Research means in terms of project or internship, especially for UG students.
Right, because I think this can be a very new pathway for UG students to take. Do you have any very simple advice that you can give from your experience to your UG students if they want to start their research paper?
See, don't start research without any solid prerequisition. Because no, that is what the important things what we need to have now. So you should be, as I told earlier also, no, they should be master in the foundations. Whatever the topics they are doing, they should learn. They should try to apply and relate the mathematics with other subjects. These are all very important, and they should have, what I feel is they should have a curiosity in mathematics, and will take you further than instead of chasing that mathematics. You should have curiosity at every step. That will definitely help you to write. And as I told earlier, again and again, I told this, I'll tell in my class also. Mathematics is meant for writing. Please write and speak mathematics.
Right. And so from the department, do you have any upcoming events or initiatives or projects that you would like to promote?
See, as usual, we conduct these events, means intercollegiate fest, convergence. We have for the PG students a separate intercollegiate fest that we call it as a Arohan, and we are planned to have so many invited talks on the. We have already a plan. We have that on the emerging areas of the mathematics, and also as a department we are applying for so many interdisciplinary projects. We have one project with life science, one project with social science. They are all applied already for the external funding, and also we applied for the infrastructure, research infrastructure. We have one DST FIST project program that also we applied. We are waiting for the result from the outside, and we conduct so many collaborative research and with other university. We have a MOU with one Malaysian Terengganu University, where our students are having a collaboration, and one of them is a co-supervisor. One of the faculty from there is co-supervisor for my PhD student. Like this, we are having a lot of research collaboration with, and almost all the faculty in my department, they have a research paper collaborated with other institution faculty, well-known faculties there. So these are some of the research collaborations we have.
That is very interesting to hear, because there's a lot of opportunities.
Yes, we have so many students collaboration also with outsiders, through the connection with faculty. We have discussions with them.
Right. Is there anything else that you want to share to anyone who is interested in mathematics or in science or in research, or any tips you would like to give students in general to our viewers?
Yeah, what I feel is that if you think about the next future in any subject is mathematics. Without mathematics, I don't think they can develop the future, because you take any subject now, including the languages you take, they use mathematics. So future of science is interdisciplinary research. I always tell the students, don't stop your studies at undergraduate. Because most of the students, they want to go for a job, they apply for the job through placement. That you will get any time. But once if you have a break in your studies, it is difficult to continue after 1 or 2 years. People will say, student, I will continue after 2 years working. I tell them, don't do that. You have a continuity now. Study now continuously. Okay, do some research. Because now science, if you want to build any nation or even nation, the important is science research should happen, not with other things. So science research will happen only our science graduates go to that level. If they stop at undergraduate and go for a job, nothing will happen to the development of research. You cannot build the nation, society, anything. So please, one mildly request is, whoever is capable, please go to PG, study, do some research, then you can go. Definitely that will lead to a job. Job will automatically come for you if you have a qualifications.
That's right. Then Dr. Pranesh, thank you so much for sharing your journey, your insights, your vision with us today. From your approach to academic leadership to the way the department is preparing the students for facing the fast-changing world, it's clear that the mathematics department here at Christ is at very inspiring hands. To our listeners, I hope you've enjoyed this conversation as much as I have. These discussions are a reminder that behind every program, every subject, every project, there are leaders that are dedicated to nurturing this talent and pushing these boundaries of education. If you're a student, alumnus, or simply someone passionate about the future of mathematics, I hope today's episode gave you a deeper glimpse into the culture and commitment that makes this department unique. Thank you for tuning into this episode of Featured HOD Interviews. Until next time, I'm Nishita Shaiju signing off.
Thank you.
Thank you.